Alright, so today's date is Friday, October 18th, 2019. We are on a minimum day. Alright, so we're doing more word problems, this time looking at tables. Oh yeah, you guys want to do the random event really quick? Alright, is there a quiet raised hand who can read our objective? Looks like Emma is first.
Enter chat and solve word problems with tables.
There it is, yeah, thank you. So the strategy is to look at the units. So if I come down here and I'm asking what is the cost of each baked good and I have the word each, I'm probably going to be doing some sort of slope. If I'm asking how much money was in the cash box, that means I need to somehow get to 0 or whatever value it's asking us. If I'm going to interpret this problem, it's going to be a little bit harder. I'll have to read it. But yeah, the units will lead us to the right answer. So in example 1, who wants to read? I think Larissa should obviously read. Okay, Kira, go for it.
Larissa is selling baked goods at a fundraiser. The table compares the number of baked goods and the total money in the cash box. There was an initial amount of money in the cash box.
All right, cool, thank you. Yeah, so we don't know how much money was in the cash box, but let's go ahead and annotate this table. So usually the way that we do this is we always start by saying, okay, if I'm going from 5 to 10, if I'm going from 10 to 15, what's the pattern on the left-hand side? Quiet raised hand for this one, Wyatt.
Positive 5.
Yes, plus 5, positive 5, however you want to think of it. Yeah, thank you, Wyatt. And what about for the right-hand side of the table? On the right-hand side, I can color code this. I can make this yellow. Charles?
Plus 10.
It is indeed plus 10. Plus 10, plus 10. Whenever you see a table, this is a really good strategy to do whenever you have a line. Eventually we'll hit quadratics at the end of the year, and that won't be true, but there it is. So the cost of each baked good is the question now. So the cost of each baked good, I'm talking about the slope. Whenever I'm talking about the slope, write it out. Slope is equal to, and I need a quiet raised hand for this one. What is slope? What is the definition of slope? You can use your definition, whoever's definition you want. Ulysses?
Slope equals delta y over
There it is, delta y over delta x, the change in y over the change in x. And usually we always think of the right column as our y, our left column as our x. But in this case, it's not going to be delta y over delta x because it's actually the baked good per, oh no, it is the money per baked good. So it is still delta y over delta x because we want money per baked good. So if I divide money divided by baked good, then I should be good. So I need to divide 10 by 5. So let's plug it in. So this is going to be 10 divided by 5. And really easy XP. Someone reduce that for us, Esha. It is indeed $2 per baked good. And units here are kind of important. So I'm going to back up here just a little bit. The answer is 2, so I'll write 2 out here. But this was $10 per baked good, which means I have $2 per one baked good, right? $2, I can come back here. $2 per one baked good. What's going on here? Command Shift Z, Command Shift Z, there it is. $2 per baked good.
There's a name for that, like when it's how much it costs for one.
A unit price?
Yes.
Yes. Perfect. So now let's go to a harder question. How much money was in the cash box before Larissa's fundraiser? Because they said in the very beginning there was an initial amount of money in the cash box. Well, how much money was in the cash box? How are we going to do that? Who has their card still? Eamon.
Well, you would subtract 5 from the highest most point in baked goods.
Okay.
And subtract 10 from the highest most point in money in the dollars.
You're correct. Why? Why is that going to help us?
That'll help us out because Larissa has 0 baked goods. Oh wait.
Yeah. So she'll have 0 baked goods, which means
that she never gained any money in the beginning.
there it is. If we go back in time to 0 baked goods, she hasn't sold anything yet. She hasn't made any money yet. So let's go backwards in time. And we don't have enough room here, so you're going to have to kind of do this in your heads. If I go backwards in time and do minus 5, or I don't know why I said minus 15, minus 5, maybe I should do that in blue. If I go backwards in time and say minus 5, then I have to go backwards in time on this side and say minus 10. And then I'll have 0 baked goods with a total of, and then it's a quiet raised hand, some easy XP here. How much money was in the original cash box? Is there anyone that still has a card? Larissa? $21. There it is. $21 before she started selling anything. Cool. So that's you guys interpreting the problem, figuring out, oh, that means baked goods needs to be 0. And that's the general rule of thumb. If it's asking for what is the money, notice that money was on the right-hand side, then you have to do something to the baked goods to get to 0. That's a very common theme in these types of table problems. Somehow make the other side go to 0 if I'm looking for money. Looking for money, the other side go to 0. All right, so from there, 21. Let's go to example number 2. Quiet raise hand to read. Who wants to read? Charles.
Ulysses wants to buy some snacks from the Chevrolet. The table compares the number of snacks that Ulysses can buy and the money that would remain in his wallet in dollars.
Perfect, thank you. So Ulysses, you're packing some lot. You have a lot of money. It looks like. So you have at least $72 when you're going to buy some snacks. But notice that with every snack that he buys, that the money in your wallet is going down. So eventually you are going to run out of money if you buy too many snacks. I have no idea what snacks are you buying. I guess we'll have to figure out how much the snack price is worth. Let's go ahead and annotate the problem. What's happening on the left-hand side of the table? What's happening on the right-hand side of the table? Is there someone that can do both of those for me? Who has their card still? Anyone? Jade? Yeah, go for it.
Okay, so on the left-hand side, you are going up by 4.
Up 4, up 4. All right.
And on the left-hand side, you are going down 18.
Minus 18 and, oh yeah, minus 18 on both of them. Perfect. And if you didn't know that, you could have done, what's 54 minus 36? And you'd get 18. You say, okay, I'm going down, so negative 18. Perfect. All right, so that's definitely going to help us. Notice that one of these questions is not how much each snack is worth. We could eventually do that. We could do 18 divided by 4, and that would be like $4.50. So whatever snack you're buying, Ulysses, it's $4.50. But how much money did Ulysses start with? We don't know how much was in his pocket beforehand. What?
$90.
How did you get that?
So when you're talking about how much money Ulysses started with, you're gonna try and get the snacks to 0. So you're gonna subtract 4 on the snack side, and then you're gonna want to add 18 to the dollar sign, and 18 plus 72. We can break that down. The 72 plus 8 is 80, and you add 10 more, which is 90. So $90.
Ooh, that's a lot of money.
I mean, you should see the amount of money difficult.
All right, so thank you, Wyatt. The next question is going to be a little bit harder. How many snacks can Ulysses buy at most? How are we going to do that?
Oh,
Ulysses, talk about yourself. What's happening?
So you like all the snacks. We'll have to divide we have to divide 18 by 4 or
That would be the cost per snack. How would that help us?
well, like, and then once we get per snack, then you could divide that. Or
Oh, yeah, I see what you're saying. So if I have $90 and I know that each snack is worth $4.50, then I could just do 90 divided by 450 to find the number of snacks. Is that kind of the line of thinking? Yeah, so that I didn't even think of that method when I was doing this problem, but yeah, that is a totally valid method. I'm going to be showing you that method and another method. So again, Ulysses is saying, okay, this 18 right here divided by 4, that is my slope. I know that if you even check it on the calculator, if you don't believe me, 18 divided by 4, 54. 4 is $4.50. We know that each snack is worth $4.50. So we're going to say if I have $90 and I divide by $4.50, so I can do this in a different color, $4.50, that will be the total number of snacks that I can buy. Because on the bottom we have units of money per snack. And when I divide money by money per snack, I'm left with just snacks. So this is probably going to be a calculator. Oh, you can probably do this without your calculator if you're tricky about this. Does anyone see how you do it without a calculator?
yeah.
Quiet raised hand if someone wants to share with the class how to do it without a
I
calculator.
already did it.
guess what?
Oh.
You can do it. You can do it.
So I can show you off to the. Oh, you got it, Wyatt?
Well, if you look at it closely, it says 4.5, and If you move the decimal to the right one, that's 45, which is half of 90. So if you do 900 divided by 45, I don't know that exactly.
But yeah, that is
20.
a good strategy. So 4.5 is half of 9.
Wait, why did you add another 0 to it?
If I multiply the top and bottom by 10, then I can get this. I can also then divide the top and bottom by, well, that's not going to really help you, by 45. You can divide the top and bottom by 5. That might help you. What is 45 divided by 5? What is the denominator? Quiet, raise hand, Kira. It is indeed 9. And whenever I divide by 5, you multiply the top by 2 and then remove a 0. So 900, and I multiply by 2 is 1800, and then move the decimal place. So 900 divided by 5 is 180. Does this problem become a little bit simpler now? 180 divided by 9? Does anyone know how to do that? Or maybe you can hide the 0, don't look at the 0. It's 18 divided by 9, then add the 0 on later.
You can only buy 10 snacks.
But each snack is $4.50. That's a lot of money.
It's not enough snacks to live off for the rest of your life.
It definitely is
Unless
not.
unless you're rationing and you're stuck on a raft.
Yeah, and you 1 foot 10.
Yes, so the answer is 20 snacks. Let me show you a different method, and then we'll move on to example 3. Because we have a minimum day, I kind of want to just... Oh, you want to go for it, what?
Yeah.
Go for it.
Can I do?
Yeah.
So, when we're trying to find how many snacks Ulysses can have, we're going to try and get the amount of dollars that he spends to the least amount. So, I would subtract by 36 on that side, and then I would add by 8 on the other side, so it would be 20 snacks.
There you go. Now, there's another way to do it. So, again, making sure that everyone is clear on... Oh, man, more things are falling down because of the AC. I just saw a jellyfish go down. So, we want to get to $0. Maybe this won't come out very nice, but this case it did. If I get to $0, I'm really subtracting by 36. Minus 36 is double of minus 18, which means plus 4. I need to double that to get to plus 8. And obviously, 8 plus 12 is 20. There's your little trick.
So you just double that number?
And if you don't like doubling it, another different method, you're correct. Yes, you could double it. But if you have 36 and 12, you could just keep adding 4. You get 16. Subtracting 18, you get 18. And keep subtracting 18 again, I get 0. And add 4 again, and I get 20. You could do it in 2 hops instead of just 1 hop where you multiply by 2. All right. And then we're going to go to our final example on the back. Example number 3. Who wants to read this one? Charles.
Eamon is running a mile from his corner. The table compares the total distance he has to run and the time since Mr. Warner started his stopwatch. Unfortunately, Eamon started a little late because he needed to tie his shoe.
All right. So, while Mr. Warner did start his stopwatch, Eamon is tying his shoe for the first part of it, and then he takes off for his mile. Everyone is understanding the question. So, how fast is Eamon running in meters per second? Am I talking about getting one of these sides to 0? Am I talking about dividing the sides? What am I talking about in this problem? Only 3 people know. 4 people, 5 people. Larissa, talk to me.
What we're talking about?
Yeah, are we talking about like an x-intercept? What type of thing are we talking about?
I think we're talking about the slope.
It is indeed slope. And Larissa, do you know the equation for slope?
Delta y over delta
It is indeed delta y over delta x. Let's go ahead and annotate the table. What's happening on the left? What's happening on the right? Someone talk to me. Kira?
On the left, he's going plus 30.
Plus 30, plus 30. Yes, you are. And on the right-hand side, you are
Plus 100.
plus 100. All right. So, is there someone that can use information from the table to tell me how fast he's running in meters per second? So, that should give you a hint as to what you're dividing by what. Asha?
100 divided by 30.
It is indeed 100 divided by 30. And is there anyone with a quiet raised hand that can reduce that fraction? You can leave it as an improper fraction. I'm still okay with that. As an improper fraction, this is equal to what, Charles?
10 over 3.
10 over 3. 10 over 3 meters per second. There's our answer. Nice and easy. It's just slope. Just divide and simplify. The key word again was per. Once I saw per, I knew I was going to divide this side by this side. And it usually always will be the right side divided by the left side. I don't think I've ever seen a problem where it switched it on you guys. All right, and then we need to know how long did it take for Eamon to tie his shoe? How many seconds? Oh, okay, so let's look at our unit here. We're in units of seconds, so we're going to be looking at this value of the table when the other side is some other number. So we need to figure out what should our distance be? What number should the distance be? And then we'll figure out what the time is once we figure out that distance. Ulysses?
0.
Yeah, the distance should be 0 because he hasn't started yet. So let's go back to 0 and then we'll figure out the time that he starts increasing. So how am I going to get back to 0? That's going to be a little bit tricky because if I subtract 100, I get to 50. If I subtract 100 again, I get to negative 50. I never get to 0. How could I possibly get to 0? Eamon?
You would need to subtract the distance in meters by half.
Ah, okay. So are you thinking of going backwards to 50 and then half?
No, I'm saying divide the just subtracting 50 by 50, which would be just subtracting 1/2 of the distance.
Like minus 50 on that side? Is that what you're trying to say?
Mm-hmm.
Okay, so if I subtracted 50 on that side, what should I subtract on the left-hand side? 15. Yeah, thank you, Eamon. So if I subtract 15, then I get back on this side, and I'm running out of room, so I'm going to continue my table down here. 60 minus 15 is 45. So I have 45 on the left-hand side of the table, and on the right-hand side, I'm doing 150 minus 50. I can do that in my head. That's really easy. That's just 100. So now I have this table value of 45 and 100. What do I need to do next? Because I'm still trying to get this 100 to 0. How can I get from 100 to 0, Kira?
100 minus 100 and 45 minus 30.
There it is, 45 minus 30. So I get 15. And Kira, what does that mean our answer is?
It took Anna 15 seconds to tie his shoe.
There it is. And that sounds like a much more reasonable answer. Maybe your shoe is kind of complex, but 15 seconds sounds about right.
So we just basically changed the table.
Yep, you manipulate the table as long as you're doing the same thing to the right side and the same thing to the left side. If you're dividing by -2 and dividing by -2, then you're in good business, yeah.
So wait, why did we use that 100?
At the very end, right down here, why did we subtract 100?
Oh, never mind.
Oh, you got it? Okay. Just in case anyone else has the same question as Larissa, we needed to get to 0, and the only way to get there was by subtracting 100. All right, that's all I have for you guys. How much time do we have to do homework? We have 37, so we have 9 minutes to do the homework. It's a good chunk of time. Good luck on the homework.